In this video, I'd like to talk about the math question of the day for Wednesday, August 16th, 2023. And with this problem, we have a right triangle, and we need to figure out how long this side here, JL, actually is. And questions like these are typically seen in geometry classes, though you might see this in a trigonometry class as well. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And there are a couple different strategies that we can use to figure out this missing side length, which we've labeled as x. One strategy is to recognize that this is a special right triangle. If this angle here is 60, that tells us this angle here at J has to be 30 degrees. And these special right triangles, these 30, 60, 90 triangles, have unique properties. So if we start with an equilateral triangle, where all the sides and all of the angles are the same, what we can do is split this triangle in half. And by doing so, we end up with a 30, 60, 90 right triangle, where this is 60. This angle here was 60 degrees for the big one, but we split it in half, so now this smaller angle is 30 degrees. So we have this 30, 60, 90 triangle, but the key point is that it comes from half of an equilateral triangle. And remember, with equilateral triangles, if we know one of the sides, we know all of the sides. If, let's say, this is y, then all of the side lengths are y, but in the bottom, we split the side into two equal pieces. So each of these will be y over 2. And from there, we can use the Pythagorean theorem to figure out essentially the height of this triangle, if we call that h. Now, I won't go through the formal proof here, but what you'll see is that h, this height, this medium side length in the 30, 60, 90 triangle, is the square root of 3 multiplied by the smallest side, which was y over 2. So if we put in actual values, it might make more sense. Let's say this is 6. That means this would be 3, and this would be 3 root 3. So that's the general pattern. And of course, we can use this. We have the long side, the hypotenuse, that will be twice as big as the small side, the side that's opposite the 30-degree angle, meaning that this is length 4. And using the Pythagorean theorem or using this pattern, we know that the middle side length is the square root of 3 multiplied by the small side, meaning this is twice the square root of 3. And that right there will be our final answer. You can, of course, verify that using the Pythagorean theorem. Now, a second approach is that we can use trigonometry. We can use our right triangle trigonometry definitions, the SOHCAHTOA, and assuming we don't know the hypotenuse, or we don't know anything about the special right triangles, we just know this angle and the two legs of the triangle, or at least we're trying to find one of the legs, but we know the other one. We know the opposite side to our angle, and we know the adjacent side, meaning that we should use the tangent function. So the tangent of 60 degrees is equal to the opposite side, which is x, divided by the adjacent side, which is 2. And solving for x, we get twice. The tangent of 60 is x, but the tangent of 60 degrees is the square root of 3. We can check that with a calculator, or remember that the tangent of some angle is the sine of that angle over the cosine of that angle, and we can, of course, use the unit circle there, though ultimately the unit circle relies on this knowledge. So, in the end, we do still need some understanding of these special right triangles in order to evaluate this trig function without a calculator. But if you do have a calculator, then you can figure out x fairly quickly using trigonometry. So in both cases, we found the same answer, that x is twice the square root of 3.